Hello, good morning.
Morning, sir.
Yeah. Okay. Uh, so after understanding how to traverse the graph using BFS and DFS and their implementation also, so we'll look into the next topic, sorting and searching techniques. Okay. See, sorting is the operation of arranging the data uh, in a given order. So you can go for having the sorted list and unsorted list. So what you are seeing is the unsorted list here, and this is the sorted list. So now we're going to understand the techniques. First, for sorting, how do we sort the given elements, unsorted elements or the unsorted list, into the sorted one? And after that, after the sorting techniques, and we are going to understand many sorting techniques now, today and tomorrow, and day after tomorrow we are going to look into the searching techniques. Okay, so what you are seeing here is an unsorted list now, and this is a sorted list. So what are the techniques that can be used in order to sort this unsorted list into the sorted array? So either in the ascending order and what are in the descending order. Now what we are seeing here is the array, which is unsorted array, sorted into an ascending list, and similarly you can also go for sorting it into a descending list also. Okay, now and again the basic types of sorting techniques. So we have internal sorting. So if all the data to be sorted is adjusted in the main memory, then it is called as internal sorting. Say for example, I have very few number of data and I want to sort them, so then you can go for adjusting all the elements within the main memory, and then you perform the sorting. This is what is called as an internal sorting. And similarly, if the data to be sorted is very large, and if you have a huge data set, and if it is not possible for you to adjust all of this large data set inside the main memory, so then it acquires the external memory also, and then this type is called as an external sorting. So where you have some data which is present inside the external memory also. So as long as the number of elements to sort is very less, and in other words, as long as the number of elements to be sorted can be accommodated or adjusted within the main memory, so we perform the internal sorting. Okay, now what we discuss now is the internal sorting techniques, because what we take is a small array and we're going to sort it, and we're not going to consider the huge set of data which is going to exceed your main memory. Now today we'll understand three methods for sorting. One is the bubble sort technique, selection sort technique, and then insertion sort technique. So what we will do is we'll try to understand how each of this sorting method works for today. So tomorrow we'll just discuss the implementation part for these things, and I'll ask you also to write, because you might have already studied these things in the C programming, correct? No? A few of the sorting, I think for the bubble sort technique you might have already studied in the C programming language. I don't know about the selection sort and insertion sort, whether you have studied or not. So there are other sorting techniques also. You have the quick sort, radic sort, and then merge sort. Okay, all these things, these three will understand for today, and remaining three more will understand in the tomorrow's class. Any idea how the bubble sort works? So I hope you people have studied this in the C programming language. So can anyone just highlight what is the logic behind this sorting technique?
Sir, from the beginning, we
we take a pair and we compare if they are, which is greater, which is equal, and if the first number is greater than the second number, we swap the thing and then check for the next consecutive pair and so on.
Okay.
And do it until everything is sorted out.
Okay. So good. And here, in order to implement this particular technique, you require two for loops. Okay, outer for loop and inner for loop. So, and we have two things here. One is the pass number, and another one is the comparison number. Now, the pass number, say for example, if you have 10 elements, so I have 10 elements in my unsorted array, and I want to sort just 10 elements, so you require 9 passes. Okay, so in general, if there are n elements, okay, then you require n minus 1 passes, and in each pass you got to do comparisons. Okay, so and in the say you're in the first pass, okay, first pass you require again n minus 1 comparisons. Okay, say I have 10 elements to sort, and the number of passes required is 9. Say 10 elements I have, and the number of passes required is 9 passes are required, and this 9 passes are tracked by using the outer for loop. I'll be writing 2 for loops for this is the outer for loop. Let us discuss about these things later. I'll just put it at a dash. So one outer for loop which is going to keep track of the number of passes, that is n minus 1, and you require a nested for loop or inner for loop, so which is going to take care of the number of comparisons. So I just open this. This is the closing for this for loop, and I have to close one more. Okay, so this is the pass number, and this is the inner for loop is for the comparison number. Comparison number. See, in the first iteration of the outer for loop, okay, so and here how many times this for loop you got to execute? So 9 times. So in the second pass or the second iteration of the outer loop, okay, second iteration of the outer loop or the second pass, okay, second iteration of the outer for loop is nothing but the second pass, pass 2. So how many comparisons are required? So you don't require 9 comparisons in the second pass, you require just 8 comparisons. So why 8 comparisons is, so the number of comparisons required decreases by 1 on every pass. Okay, the first pass you require 9 comparisons. So very next pass you require 8 comparisons. That means in the first pass, in the first iteration of the outer for loop, so this inner for loop is going to execute for or iterate for how many times? 9 times. If I assume I have taken 10 elements. In the second iteration of the outer for loop, so the inner for loop has to iterate for how many times? 8 times. Okay, and in the third iteration of the outer for loop, the inner for loop should iterate for how many times? 7 times. Now what's happening? The number of comparisons required in each pass is decreasing by 1. Okay, sir, what will happen if I go for comparing or doing all the 9 comparisons in all the passes? Nothing will happen. Okay, see, in the first iteration of the outer for loop, I go for performing 9 comparisons. Second also I do 9 comparison. Third also I do 9 comparison. Fourth also I do 9 comparison. Till for all the 9 passes I will be doing 9 comparisons. Okay. Now how many comparisons will be doing? So if you're doing, so on all the passes 9 comparisons, so you will be doing it as 9 into 9. Okay. So in each pass you are doing 9 comparison, 9 into 9, 81 comparisons you are doing. Okay, people are following?
Yes, sir.
So any point of time you got to make your program efficient. Okay, so it is not necessary for you to do 9 comparison in each pass. Okay, only the first pass you got to do 9 comparisons. So once you are done with the first pass, after you finish doing the 9 comparisons in the first pass, what will happen is, so if you are arranging the elements in the ascending order, the biggest element will get placed in its proper position. The biggest element in the unsorted array will go and sit in its proper position. So in the second pass, it is not necessary for you to compare the remaining elements with that biggest element which is already taken its position. Okay, so that is the reason we say, so we will be decrementing the number of comparisons by 1 in the second pass. So and in the third pass the number of comparisons will be decreased by 2, so something like this. So with this, what you are doing now, so say I have written a program for performing 9 comparisons in each pass, and the person Y has written the program for program such a way that, so the number of comparisons is reduced by 1 on every pass. Now whose program is much more efficient? So I am doing unnecessary comparisons. I'll also get the correct result, no doubt, but I'm doing what? Unnecessary comparisons here. 81 comparisons I'm doing, even though it is not required. But this fellow Y, by implementing the inner for loop in such a way that the number of comparisons reduces by 1 on each pass, so he has written a much more efficient program. So it goes like this. Now we'll try to understand how the bubble sort logic works, and when we go to the implementation, probably tomorrow you'll get to see the all these for loops and all. Okay, and selection sort will come after finishing the bubble sort. Okay, yeah. So bubble sort. So this is the very vague algorithm that is written, very high level algorithm that is written in terms of natural language. So the algorithm of the bubble sort includes 2 steps which are repeated until the list is shortened. First, what we do, compare the adjacent elements. If the element on the right side is smaller, then we swap their positions. If the element on the right side, say for example I'm trying to sort them in the ascending order, if the element on the right side, if it is smaller than the element which is on the left side, we go for swapping them. Okay, so we exchange their places. So compare first element, second element, and so on. Completion of pass 1, that the largest element is in its last position. Okay, what we do, so we keep doing this. So we keep doing these comparisons. Once you complete the pass 1, what will happen? So the biggest element or the largest element will occupy the last position, or in other words you can say it will occupy its proper position when you are arranging the elements in the ascending order. So similarly, if you are trying to arrange the elements in the descending order, so the smallest element will get placed in its proper position. Okay, now and this process we keep on doing, repeating. So in at the end of pass 2, what will happen? If you are arranging the elements in the ascending order, the next biggest or the largest element will occupy the last but one position. In the third pass, so at the end of the third pass, what will happen? The next biggest element is going to occupy the last but third position, and the same process we repeat until all the elements in the unsorted array gets sorted. So that is what is the bubble sort technique. Implementation for this we'll discuss in the next class. Now we'll try to work out with the examples, okay, and see how the logic works. So I have the unsorted array taken here. So this is the unsorted array which we have taken, 50, 10, 30, 20 and 40. So I am in the first pass now, pass 1. How many comparisons, how many elements are there? You can just have a look. 1, 2, 3, 4, 5 elements I have, and I have written here the number of passes required is what? Maximum number of elements minus 1. So the number of elements here is 5, minus 1 is 4. Totally you require 4 passes. Okay, no? In order to sort this unsorted array using bubble sort technique, the total number of passes required is 4. What is the meaning of this? So 4 is nothing but the outer for loop should iterate for how many times? The outer for loop, what I wrote here, you should be going for writing in such a way that it is going to iterate for how many times? 4 times. So this is what the pass number, and then you can go for comparing. See, this is the pass 1 comparisons what we are doing. See here. So this is comparison number 1. So this is comparison number 2. This is comparison number 3, and this is comparison number 4. So in pass 1, the first pass, how many comparisons we have done? 4 comparisons we have done. So the number of comparisons is equal to, again, the max minus 1. In the first pass you require 4 comparisons if there are 5 elements. Now what we are doing here in the first comparison, I am taking the first element and second element, I am comparing them. Now, as per the algorithm that we understood, when you compare, if the element on the right side, okay, or the next element which is at the index 1, if it is smaller than the element which is there at the index 0, okay, or the element which is on the right side is smaller than the element which is on the left side, what you got to do? You got to go for swapping them. Okay, this is what the first comparison I'm doing. I'm just checking whether the element on the left side is bigger than the element on the left side. Yes, element on the left side is bigger than the element on the right side. I have to go for a swapping. That means this is the biggest element and this is not its proper position. Now I go for swapping them. So what you can observe here, 10 and 50 are shorted. Now after that, I'm going for comparing, doing the second comparison. How the second comparison is done? So in the first comparison, we compare the first element with the second element. In the second comparison, we compare the second element with the third element. Again, I'm comparing 50 with 30. Again, the element on the right side of the comparison that I'm doing, that is 30, is lesser than what? 50. So 30 is lesser than 50, so you require one more swapping. So it is swapped here, and what you can observe is 30 has taken this position and 50 has taken this position. So next in the third comparison, so these are all the comparisons what we are doing in pass 1. So pass 1 are the first iteration of the outer for loop. Now here I am comparing again 20 and 50. So since 20 is again lesser than 50, so they are swapped. Okay, so 20 takes the position of 50 and 50 takes the position of 20. Okay, next. So I'm doing the fourth comparison now. Okay, comparing in the fourth comparison, I'm comparing the fourth element with the fifth element. You can see here. So again, the fifth element is lesser than the fourth element. Swap is required. So I'm just swapping this 40. I'm assigning this 40 to the position of 50 and 50 to the position of 40. So they are swapped. Now all the four comparisons within the pass 1 are complete, and you can see now the 50, which was the largest element in the unshorted array, has taken its proper position. Okay, so 50 is the largest of all these elements, and it is already in its proper position. So when I go to the second iteration of the outer for loop or the pass 2, so this I need not do any comparison with 50. So my comparison is to stop at this place. So now in the second pass, I don't require 4 comparisons, so I just need only 3 comparisons. Okay, even if you're doing fourth comparison, it is waste of time and waste of the CPU cycles and the cycles. So you are unnecessarily wasting the most precious resources of the computer system by doing unnecessary comparison. But still, you get the output. Is this clear?
Yes, sir.
Yeah, and what is written over here is the index of the elements which you are comparing. So here in the first comparison, I am comparing the element which is at the 0th index with the element which is present at the first index. So these are the indexes. So this is at the 0th index, and this is the first index, and this is at the second index, and this is the third index, and this is the fourth index. Okay, and here 1, 2 says we are comparing the element which is at the index 1 with the element which is there at the index 2, and the same thing is repeated. Okay, so now this is the end of pass 1. So as you can observe, at the end of pass 1, you have the biggest element placed in its proper position. Now this is what happens. So if you are similarly trying to arrange the elements in the decreasing order, at the end of pass 1, what will happen? The smallest element will get placed in its proper position. Understood?
Yes, sir.
Okay. Now we are in the pass 2. So pass 2, or else you can also call this as second iteration of the outer for loop. Second iteration of outer for loop. Second iteration of the outer for loop. So you can just observe again. when we move back to the second iteration of the outer for loop, so the inner for loop again gets initialized and starts all the way from the beginning. Okay, so again now we are comparing. So this is the first comparison what we are doing in the second pass. 10 is being compared with the 30 again. So yeah, 10 is already smaller than 30. 10 is already smaller than 30. It doesn't require any swap. Okay, so because the element on the left is already less than the element on the right, now we just skip it. We don't go for swapping. Okay, next, but still to skip, I have to check whether it is lesser or bigger, right? So this comparison we have done it. Now in the second comparison I'm doing. So say pass to second comparison, we are comparing 30 and 20. Now in this case, if you just look, the element on the right is smaller than the element on the left. Now it requires a swapping. Oh. Ten, 30, okay. Yeah, this requires a swapping. Sorry, this is not correct here. This should be 20. Make a note of it, please. And this is 30. So we have made a mistake here. Is it clear?
Yes, sir.
Now here we have done a swap. Swapping is required here. So 20 and 30. So please, small correction here. Next, what we are doing, we're comparing this 30 with 40 in the third iteration. Now here in the second comparison, when I do it, okay, so 30 is bigger than 20, so swap is required, 20 and 30. Now we're comparing 30 with 40. So again, this is already smaller, 30 is already smaller than 40, no swapping is required. Okay, 30 and 40, sorry, this is 20 and this is 30. Okay, and see now the second largest element is has got into its proper position, and the first largest element is also in its proper position, and the number of comparisons with what we did was 3. Okay, now pass to, I think the same mistake is communicated everywhere. Okay, let me change it, 20 and this is 30. Now what we are doing, we are comparing this 10 with 20. Again, it's 10 is smaller than 20, doesn't require any swapping. So this is 20, this is 30. So it doesn't require any swapping. So again here also, so first comparison no swapping required. So second comparison I did and there is no swapping required. Okay, sorry, this is 20 and this is 30. So now I have the third largest element placed in its proper position, second largest element in its proper position, and the first largest element in its proper position. That is what is pass 3. Next, what is happening? Pass 4. This is 20. This is 30. Now all these three are already taken their positions. Now this is the only comparison what we are doing in the last pass. So this is the comparison, first comparison, 10 and 20. So no swapping because 10 is already lesser than 20. Okay, so now even 10 has also taken its proper position, and this is what the shorted list is. Sorry, 20 and this is 30. So there was a mistake, please make a note of it. So this is the shorted list. Is it clear?
Yes.
Okay. I'll give you one more. Try to solve it. Okay, so take this 5 4 3 2 1. So go for sorting them in ascending order using the bubble sort technique. Okay, now how to do that? So I'll write here pass 1. So how many passes required?
4.
So number of passes is equal to 4. So pass 1, let me write 5 4 3 2 1. Now I compare this first comparison. I compare the element which is at index 0 and 1. So I'm trying to arrange them in the ascending order. This is the first comparison what I'm doing. Now since the element on the right is smaller than the element on the left, so it requires a swap 4 and then 5. Let me write 3 2 1. Now in the second comparison I go for comparing the element which is at index 1 with the element which is at index 2. So that is 5 and 3. So this is what the second comparison we are doing. So now 4, again the element on the right, when I am doing this comparison, 3 is lesser than 5, so it requires a swapping 4 3 5 2 1. Now next comparison we do by taking the element which is under index 2 and index 3. So this is the element which is, this is at the index 0, this is at index 1 and this is at index 2. So this is the comparison what we are doing now. This is the third comparison. Again, so 5, so this is the worst case array which I have taken 5. So 5 and 2, again there is a swap required 2 5 and 1. So now the next comparison will happen between the element which is present at the index 3 and the element which is present at the index 4. At index 3 I have 5 and index 4 I have 1. Okay, so this is the comparison that is happening. This is the fourth comparison. 4 3 2 1 and 5. So now at the end of pass 1 we have completed the pass 1. So you have the highest element taken its position. Okay, so this is the end of the pass 1. Now pass 2. Pass 2. Now what we do, let me write this 4 3 2 1 and 5. Now you take the again it starts from the 0 comma 1. So compare the elements which are at the index 0 and 1, that is 4 and 3. The first comparison which we are doing in the second pass, again this is smaller than this, so swap is required 3 4 2 1 5. Let me put a square to this because this has already taken its position 5. Now here in the second iteration of the inner for loop, so we are comparing 1 and 2, element which is at index 1 and element which is at index 2. So these two are compared, these two are compared, and this is the second comparison what we are doing in the pass 2. So 3, swap is required 2 4 1 and then 5. Now next what we are doing is we are comparing the element which is under index 2 and the index 3. This is the last comparison in pass 2. What we do, 3. This is the third comparison. So 3 2 1 4 5. So now we have the second largest element also taken its proper position. So 4 and 5, they are in their proper position right now. Okay. Next is pass 3. In pass 3, let me write here 3, 2, 1, 4, 5. So these two are already in their proper positions. Now we are comparing now 3, the elements which are at index. So if you are asked to trace the bubble sort program, sometimes they will ask you to trace also. This is how you got to do it. So 0, 1. Now this is the comparison what we are doing, the first comparison. So 2, 3, 1, 4 is already in its position, and 5 is also in its position. So next comparison is between 1 and 2, the element which is at index 1 and 2. So this is the second last comparison of pass 3. So 2, 1, 3. Now the third largest element of the array is also taken its correct position. So all these three are in their proper positions. Next is the last pass. So pass this is pass 1, pass 2, pass 3, and this is pass 4, the last pass. 2, 1, 3, 4, 5. So same way you have to do if you are asked to trace it for the bubble sort logic. So this is the comparison we do, the first comparison. Since 1 is less than 2, there is a swap. One, 2, 3, 4, 5. The shorted array. Okay. Clear, right?
Yes, sir.
You understood how to trace it. Okay. So we'll look into the algorithm along with the implementation part for this in the tomorrow's class. Next, I'll go to the next sorting technique. Selection sort. Okay. So here in selection sort, the algorithm depends on the 0th element majorly. Okay. So what we do now, we take the 0th element of the array, compare it with the first element, and if the element at the right is found smaller, assuming we are trying to arrange it in ascending order, if the element at the right is found smaller, then their positions were swapped or exchanged, as we did in the previous algorithm, bubble sort algorithm. So same procedure is carried out with all the elements of the list, resulting into a fully sorted list. So what we were doing here, we in the previous algorithm, we used to take the first two elements, compare, and then the second and third element, and then third and fourth element. This is how we used to solve it. But now here it is completely dependent on the 0th element. So we take the 0th element and we keep comparing that with all the remaining elements of the array. That is how the selection sort algorithm works. Okay. Now we'll have a look at the tracing path. Okay. So this is what the unsorted array we have, and here also the number of passes required is n-1. Okay. That is 4 passes, because we have 5 elements here, 4 passes are required. And this algorithm, it was little different from the bubble sort technique. What we do now, so we wish to compare the adjacent elements, keep comparing the adjacent elements in the bubble sort technique. Now what we do here, we take the first element and we compare that with all the remaining elements of the array, and we go for swapping appropriately or exchanging the elements appropriately. So this is the unsorted list. Now what we are doing, as the selection sort algorithm told, take the 0th element and keep comparing that with the remaining elements of the array. So I'm taking the first element which is at the 0th index and the next element which is at the first index. I'm comparing them. Okay. Now since the 15 is smaller than compared to 23, so we have done a swapping in the next thing. So swap 15 is swapped with 23, and the resulting array is 15, 23, 29, 11 and 1. So next again the first element. Okay, so first element earlier before comparing 25 and 15 was 23. Now after comparing 25 and 15 and exchanging, the first element now is 15. Okay, so the instead of saying it as a first element, I have to say it as the element at the 0th index. Okay, people are following?
Yes, sir.
The first element here before comparison was 23, but now the first element is 15. So instead of saying the first element, what you have to go by here is you have to go by the 0th element. In the first pass, we compare the element at the 0th element with all the elements, remaining elements in the array. In the second pass, we go for comparing the element which is at the first position with all the remaining elements, something like this. Okay, all the elements which are towards the right side of it. Now 23 was the first element. I am comparing 23 with 15, and since 15 is lesser than 23, it is exchanged. Now again I take the element which is at the 0th index, and that is compared with the 29, the next element here. Okay, so because it's already done with 23, 29. So now when I do this, so 15 is already smaller than 29, so no swapping is required. And again in the third comparison, so the element at 0th index is 15 itself. That 15 again is compared with 11. So now 11 is smaller than 15, so swap is required. So swapping is done. So 15 and 11 are exchanged. So 11 is here. Now 11 has taken the position of the 0th element now. Now I'm comparing 11 with 1 next. So swapping is required. So 1 has taken the position of what 0th element. So and then this. Now you can just observe now. So the element which is smaller has taken its proper position right now. Okay, and how many comparisons we did again here? 1, 2, 3, and then 4 comparisons. Here also the number of comparisons required in first pass is equal to the number of passes. Now what happens in the second pass? So second pass, we know that this has already taken its proper position. Now I'll go for taking the second element from my array, updated array, and I keep comparing that second element with the remaining elements or the rest of the elements in the array. Okay, so 23 we are comparing with 29. So 23 is already lesser than 29, so no swapping is required. Oh, sorry, here also the same problem. This is 23 and this is 29. Okay, it remains the same, no swapping, because 23 is already lesser than what? 29, 23, 29, no swapping. And next, I think I have to rewrite it. Let me go to, instead of using this, let us not use this. I'll take the same sequence, but we will solve our own. So 23. The sequence, let me write down. So 23 it is 23, 15, 29, 11 and then 1. Now before I upload this PPT, so I'll do the corrections and I'll upload it. Okay, so 23, 15, 29, 11 and 1. This is my unsorted array. So we are applying, and the number of passes required is 4. Passes is equal to 4 because n minus 1 it is, 5 minus 1 is 4. So pass 1, I'll write my numbers 23, 15, 29, 11 and 1. Okay. Now I compare these two now. Now since 15 is lesser than 23, so I am comparing the element which is at index 0 and 1. You just write this also. Now 15 and 23 are exchanged. Then 29, 11, 1. Next we go for doing the comparison between the element which is at 0th position and the second position, 0, 2. Now 15 and 29. Now, so 15 is already lesser than 29, no swapping is required. So 15 I'll write as it is, and then 23, and then 29, 11 and then 1. So in the next comparison, so we go for comparing the element which is at index 0 and index 3. Now that is 15 and 11. So now 11 is lesser than 15. 11 takes the position of 15 and 15 takes the position of 11. 23, 29, 15 and then 1. Next we go for comparing the element which is at 0 with the element which is at 4. So 11 with 1. So swapping is required. 1, 23, 29, 15 and 11. Now 1 has taken its proper position now. So this is the end of pass 1. So next is pass 2. So 1 is already in its proper position. Next is 23, 29, 15, 11. Now in the pass 2, you are comparing the element which is at index 1 with the element which is at index 2. Now it is 23 and 29. 1. Now 23 is already lesser than 29, so it takes the same position. 23, 29, 15, 11. In the second comparison, we go for comparing 1 and 3. So 1. Now this is what we are doing now. Now 15 is lesser than 23, so 15 takes the position of 23, and then this 29 as it is, and then 23, and then 11. Next, 1 is compared with 4. 1. So 15 and 11 what we are comparing now. So 11 is lesser than 15. 11 takes the position of 15. So 29, 23 and then 15. Now we are done with the pass 2 now. So at the end of pass 2, what you can now notice is, so the smaller two elements have taken their proper positions. Okay. Next pass 3. Pass 3. So 1, 11, they have already taken their proper position. Next is 29, 23 and 15. Now in the first comparison of third pass, we go for comparing 2 and 3. So that is 29 and 23. So 1, 11. So since 23 is lesser than 29, swap is required. 2, 3 and 2, 9. Swap is required. And 15. Next, we go for comparing 2 and 4. These two are being compared. 1, 11. So since 15 is lesser than 23, 15 takes this position. 29 and 23 comes here. And this is the end of pass 3, and you can observe 3 elements have taken their position. Okay. Next, pass 4. One, 11, 15. So they have taken already their proper position. The remaining is 29 and 23. Now here you are comparing 3 with 4. This is the last comparison of last pass. So 23 is lesser than 29. Swap is 1, 11, 15, 23, 29. This is the final shorted array. So hope it is clear.
Yes, sir.
Okay. Now similarly, try to do it for this. The sequence which I gave you for the bubble sort. 5. Worst case array we will take. 5, 4, 3, 2, 1. Okay. Try to write by yourself for this. Now I'll go to trace for this unsorted array using the selection sort. Okay. Now we'll go for insertion sort, the third one. Okay. Insertion sort. So this method, insertion sort, we generally use when we are dealing with the small numbers. Okay. So we don't prefer using the insertion sort if you have a larger array. Okay. It is preferred to use only on a smaller array. So application of insertion sort is used in when you are searching for the greater value or the smallest value from the array. So I want to find what is the bigger maximum element in the array, and or I want to find the what is the smallest element in the array. Then I go for using this. Okay. Now how the insertion sort works. Okay. See here. In insertion sort, the elements are compared and inserted to respective index place. It starts with the comparison of first and 0th element in pass 1. In pass 2, the second element is compared with the first and 0th element. Okay. So we go like this. In the first pass, we go for comparing the first and the 0th. In the second pass, we go for comparing the second element with the first and 0th element. So doing so with all the elements in the list, appropriate element is inserted by shifting elements on right. This is what we do. Shifting elements on right. So okay, this I'll understand when I go with an example. I'll show you. Okay, this is the algorithm. We'll come to this later. Let us not worry about this algorithm right now. First, we'll focus on the examples. So again, I have this array, unsorted array. Now in the first pass, as I mentioned, we go for comparing the 0th and the first element. That is what I am doing. Okay. See, 57 and 75 I am comparing. Since 57 is lesser than 75, So you can observe they are swapped here, 57 and 75. So what is the next thing I'll be doing? So next thing what I'll be doing is comparing this with this. Now what I've done in the first pass here, I've compared the first element with the element which is present at what? 0th element. Now I've found that 57 is lesser than 75. Now 57 I put here, and this 75, what this arrow indicating? So if I want to put this 57 here, this 75 should be shifted here. Yes or no? This is what the shifting, and this is what the comparison. So I'm comparing the element at the first index with the element at the 0th index, and I found that the element at the first index is lesser than the element at the 0th index. Now what is that I am doing? I go for shifting this 70. I just copy this 57 to some temporary variable, and I perform the right shift of this 75 from the first position to 0th position to first position. And then 57, which I have copied it to the temporary variable, say for example temporary variable I have. So this temporary variable, in temporary variable you can find 57. That 57 I'll write it to this first position. OP people understood what I'm saying?
Yes, sir.
So this upper arrow, what I'm doing here is a comparison. I'm comparing 57 with 75. Now when I compared, I found 57 is lesser than 75. So the moment I found 57 is lesser than 75, I'll just copy this, take this element to temporary. Temp is equal to 57. Okay, that means now I've backed up this number. So this 57, the element which is present at the first index, is backed up to this temporary variable. Now I go for shifting this 75 to the first position. When I shift this 75 to the first position, what will happen? This 57 which is here gets overwritten by what? 75. Okay, and this is also 75 since I've already shifted. Next I have 57 in my temporary variable. I go for assigning this 57 to this place, and this is what the status you are seeing after everything is done. Hope you understood?
Yes, sir.
Okay, now we'll see what happens in the second pass. So pass 2, see pass 1, you compared the element at the 0th index with the element, first index with the element at the 0th index. In the second pass, you compare the element which is at the second index with the element which is at 0. See, this is what the comparison I'm doing. I'm comparing, so this is the status, 57, 75, 25, 57, 75, 25 after the first pass. Now I'm comparing 25 with 57. This is what the comparison I'm doing. Now when I compared this 25 with 57, I found that 25 is lesser than 57. Now what is that I need to do? I have to copy this 25 to temp. So temp is equal to 25. Next what I have to do? I go for shifting this from the 0th index, all the elements I go for shifting them towards the right. Okay. So what I'm doing now, this 57 gets shifted from here to here. So first I'll shift this. So 75, I'll shift from this position to this position. So 25 will take the position what? So 75 will take the position of 25. And this 57 will take the position of 75. So this 75 will go and override this 25, and this 57 will come and override this 75, and I have still 57 here, but it should be overwritten by what? 25. I take this temp value and I'll write it here. From the temp I go for filling this 0th position. Now 25, 57, 75. OP understood?
Yes, sir.
So this upper one is the comparison what you are doing, and after you do the comparison, and if you found the element on the right is smaller than the element on the left, we go for shifting, performing the shift operation. So this is what the shift operation which you are doing, shifting the elements towards the right. Is that clear?
Yes, sir.
See, when you, after tomorrow 3 more techniques you'll understand. So when you have say 6 to 7 techniques, what will happen is it will confuse you when they ask you in the exam. So do the insertion sort. So you'll confuse and you'll do the selection sort. So you got to be careful, and you have to practice each one of them multiple times, and you got to remember them properly. So because the most thing is you'll be knowing everything, but what will happen is in exam, so you'll end up with confusions. Okay. That is what I'm telling from my experience. Okay. In the past 3, now I have to compare the element at 0th index with the element at, third index with the element at the 0th index. So this is the status now. The previous status is 25, 57, 75, 19 and 4. 25, 57, 75, 19 and 4. Now I am comparing 19 with 25. Yes, 19 is smaller than 25. Now I assign 19 to temp. See, without assigning to temp, if you do, what will happen? If you go for shifting, so this 19 will be losing permanently. Okay, so I don't want to lose permanently. Without copying it to temp, if I go for shifting, what will happen? Immediately this 75 gets shifted here, the 19 will be overwritten by 75, 19 you're going to lose it permanently. That is the reason we back it up before shifting. Okay, I just find, so yes, 19 is lesser than 25, and immediately I go for backing it to some temporary variable, temp is 19, and then I go for performing the shifting operation. Now again I'm shifting. So 25 comes to this position, and 57 comes here. So strictly speaking, you have to start writing from here. For 75 to this position, 75, and then 57 here, and then 25 here, and then finally you go for copying this 19 which is available in temp to this position. And this is what this status you are seeing now. Correct, right?
Yes, sir. Okay.
Next, in the past 4, you take 4, the element which is at the 4th index, compare that with the 0th index. So 4 and 19, yes, again 4 is less than 19, so copy it to temp. Temp is equal to 4, and then shift the 75 here. So in the 57 we will overwrite this 75, and this 25 we will write this 57, and this 25 will be overwritten by 19, and finally 4 occupies this position. So this is what you are saying. Understood, no?
Yes, sir.
The end of pass 4, you have all the elements sorted. Okay. So same thing. Now what we have understood is for the increasing order. Same thing can be done for the decreasing order also. For the increasing order, whenever the element on the right is smaller than the element on the left, I was swapping. So if you are doing it in the reverse order, in the decreasing order, if the element on the left is smaller than the element on the right, then you go for swapping. Okay, so the same thing can be done for that also. So we'll stop here, and tomorrow we'll go for understanding first the implementation part for all these 3 techniques, and then we will learn 3 more techniques. Okay.